time from COVID, and we are a few minutes before the event. Actually, it's 3:58, so 2 minutes to go. And for those of you that are already in, welcome to this webinar. May I ask somebody of you to type into the chat window if you can hear me clearly, so that I know that everything is set up correctly. Perfect. Thank you, Alan. You were the first. I don't have a swag, else you would get something. Fantastic. Thank you, guys. Good. And then the next check. Do you see the slides? You should see our nice graphic that you have seen in the invitation as well. Cool. Good. That's fantastic. So everything is set up. And as always here in Switzerland, people are right on spot or even before, so that we can start at 4 p.m., which is pretty soon. So it's 4 p.m. Thanks everyone for being on time. Thanks everyone for joining here. To be as punctual as you are and to respect your time, we start exactly at 4 p.m. Thank you so much for joining us here at our webinar series. This is actually the first webinar that we do together with AWS here at COVID, and it's really great to see that the response from the invitation list is so great. We had quite a few registrations, so thank you so much that you joined, that you show interest, and that you actually join here in the webinar as well. So by now it's more than 50% of the registered people that are attending, which is really great. Thank you so much for that. So what are we doing? Why are we here? You have received the invitation to the webinar series, and as this is webinar 1, we are really starting at the very bottom. It's really an introduction to AWS, and AWS has asked me to do that myself because they told me you can do that as good as we can, so I'm handling that myself. As a very basic introduction into what AWS is. I even start what cloud is. Even if you have heard that before, you probably will have a bit of takeout as well. So you see here up our badge that we have received as COVID from AWS probably 4 weeks ago, and we are really proud that we are one of the very few AWS Advanced Consulting partners here in Switzerland. If you go to Partner Finder, you will find probably 15 or 20 of those, but probably 60 or 70% of those are the big global players like the Cognizant, the Accentures, and yes, they are here. But if you really look for the Swiss partners, there are really very few advanced consulting partners, and we are probably the smallest of them because we are just 4 or 5 years old. So it's really quite an achievement that we have been awarded that advanced consulting partner badge from AWS, and we work really closely with them to implement AWS solutions for our joint customers. For those of you that haven't heard who we are, I will give a short introduction of COVID, I think, in the next slide. So the agenda, what we are talking today is a very quick cloud primer. What is cloud? What are the different models? Because if I have discussions with my clients, I quite often see that people are confused. What is multi-cloud? What is hybrid cloud? People get by now what is public and private. That's almost in the name. But there are quite a few confusions out there what the different cloud models are. And after we have that behind us, we go into the AWS overview. As announced in the invitation, we look at what is an account, how do you build networking, how do you secure the whole thing? Because AWS is a public cloud, it's really important that security is top priority. And then we look at a few of those many services that AWS has. A particular look at compute and at databases services that they offer. And in the cloud native area, very often DevOps is coming up as well. It's quite a trend, quite hip here in Switzerland too. So we look at a bit at DevOps and how cloud can help here as well. A bit of housekeeping, obviously, as well into the webinar. As you probably have seen by now, I'm the only guy talking for the next probably 40 minutes or so, and maybe 35 minutes. So if you have a question, please put it into the chat window. I will look at that. I had a dual screen setup, so I should see both the PowerPoint, or it's actually G slides, and also the chat. So put in the questions there, and I will try to answer those as they come up, or at least at the end when I'm through the slides. So who are you listening to or watching this webinar? So the company behind this is Copit. By now we are a corporation, so we have changed from a GmbH to an AG probably half a year ago because we have grown so much. Our focus is clearly on AWS and everything cloud, everything in the cloud world. So basically, it's AWS as a platform, AWS with all its services, but we also do containers and Kubernetes. That's quite a big thing that we do. Then we have a dedicated team working on automation stuff. So they are really champions in Puppet. But we also do other technologies like Ansible and Chef, but they're really strong on the Puppet side. And then we have people doing classic cloud consulting, so helping clients on the cloud transformation, building plans, migrations, cost analysis, stuff like that. And then we have a small arm that is also building in the IoT space, particularly our CEO. He is quite keen on IoT, and we do have an IoT platform that's developed on AWS, where we are putting up sensors and stuff, where we can visualize those metrics and so forth. And to myself, Marco Koenig, maybe some of you have worked with me before. Switzerland is quite small, so you may have bumped into me, particularly through my years at Cisco. I was 15 years there. Then after my years at Cisco, I went to Australia. So I was there 2015 up to 2018. And had there quite some exposure to AWS. So I worked there at two AWS partners and learned there a lot about cloud stuff. So all AWS, all cloud native, containers, DevOps, even serverless things back in 2016 was quite amazing. That was really a cool time. That also improved my English quite a bit. So I struggle less with English since I have been in Australia. So that was a nice side effect as well. And the best thing is my kids, two of them, they are almost native English speakers by now. Just 3 years of Australia helped them quite a bit. So when I came back to Switzerland, I became a partner at Copit. I have known the folks before my time. During the Cisco time, I bumped into some of those folks. And when I came back, I joined Copit. And since then, we have focused quite a bit on AWS. On the certification side, I do hold 8 AWS certifications, including the DevOps Pro and the Solution Architect Pro. So these are quite heavy certifications. I recently passed the Solution Architect Pro, and that was quite challenging. So if you're up to a challenge, go to those DevOps and SA Pro certs. They will stretch you certainly. And about 2 years ago, I also did the CKA, the Kubernetes admin, and in the past I did a lot of VMware and Cisco certification. And obviously, I do have hands-on with AWS, GCP, Azure, all of these platforms since quite a few years. So now let's go to the interesting stuff. Why cloud? Why are companies embracing cloud? And we, as a company, we actually see a big uptick in incoming requests from clients, and not even because of Corona. Even before that, we had a lot of requests to help companies move into the cloud area. And here a few of the things what we see from clients, why they are talking to us, why they want to do a cloud transformation. So one of the biggest things is cost transparency. So companies really don't know what they are paying to run applications on their on-prem setup. And as you probably know, with cloud, you get full cost transparency. So you see each gigabyte that you consume, each gigabyte that you provision, and each gigabyte that is processed, not each CPU cycle, but each CPU cycle second, or the memory, or all the services, you see that down to the second, what it really costs. And you obviously can map that to the application, so you have full transparency in terms of cost. Quite often, companies want to expose their applications to mobiles, to iPhones, iPads, Android devices, whatever, and that means they need to be public. So that means they need to be accessible. People don't want to start clumsy VPNs to access applications. They just want to open the app as they open today Gmail, and they want to get access. And for that, the applications, they need to be on the internet, and if they are public, just put them onto the public cloud. Then many companies talk to us because they want to have their DevOps, their agile software development more linked to DevOps principles, to DevOps technologies. And we see here quite a push from clients to start use those technologies with cloud platforms as well. Then artificial intelligence, that's something really hard to do on-prem. If you have a small model, that's easy to run. You can even run it on your laptop. But if you have big models, big training sets with petabytes of data that you want to train your models on, it's probably much easier to run that in the cloud. Hire a couple of hundred GPUs, run the data to those GPUs, pay for that, but then give it back so that the next customer can use it. And the big topic is also auditability. What do I mean with that? Because everything on the AWS cloud or on any public cloud is provisioned via an API. It's also super easy to audit what is happening. So you can really see what person, what script, what process did what, did provision, what kind of thing. And you even can do that on traffic that is coming in. So for example, traffic that is reaching S3 buckets or files that are open and things like that. That's really easy to audit what is going on. Imagine that in your on-prem network where you have Cisco and F5 and HP and VMware and Oracle databases and Windows and Linux and all of that. If you need to audit that, it's super hard with all these different technologies. And then there is security. So these technology stacks have become so complex with all these different tools and technologies in there. That's super hard to secure that, and it's really hard to find security people. So with these public systems, they have to be really secure, securely built, and also secure from the beginning, that it really works well. And I was really surprised when I came back here to Switzerland a bit less than 2 years ago. I went to a banking event, and one of the private bank CIOs stood up and raised his voice and said, I'm really going to the cloud because I cannot secure my own on-premise environment anymore. I don't find the people, and it has become too complex. I rather rely on Microsoft or AWS or Google security engineers that really build security in from the beginning. That was quite an eye-opener for me when I heard that. Other things that I see as drivers is operational costs. So I don't say that running in the cloud is cheaper, but because you have so much cost transparency, there is an opportunity to bring down costs because you really see where you spend. Another thing is data stuff, in-memory databases, analytics, big data. These are quite demanding. In-memory databases, all flash, all these things, putting up 4 terabytes or 8 terabyte servers times X is quite expensive. So here the cloud can help quite a bit as well. And I mentioned that before, Agile and DevOps is quite a big driver too. And I have here a few slides to explain that in more detail later on. Good. And then there is a comment from Simon. I see that. Thanks for that, Simon. Yes, so Simon mentioned that the flexibility in covering fluctuation of resource needs is also a great thing. And that's absolutely correct. Thanks, Simon, for that comment. Absolutely. So if you have an application where you can auto scale, that's fantastic to do that in the cloud because you pay by the second or by the minute, depending on the service. And if you really can scale up and down, or for example, in the night you scale down, you can save. So for example, shut down your development environments or during the night, scale down testing environments when you don't need them. That can be quite a cost saver. That's the journey to the cloud is quite often this what it should be. So people start with putting in workloads from development and test, and then they want to move over to new applications, and then they want to put their web presence with digital, and then going more and more into mission critical apps, and then at the end all in. In Switzerland, only very few companies actually are really all in. That's very different in Australia. They have started that journey probably 6 years ago. And even in 2016, 2017, I have worked with multiple clients that have been all in already. All in means you don't have any service anymore, and all your applications are in the cloud. So that's what everyone preaches, what everyone hopes to get to, and that's actually a very good plan. But often it looks like this. And I know this is a bit meme-like, but I do work with quite a few clients, or my colleagues work with clients where it is exactly this. So there's a big plan, people want to move workload, and then the politics starts. Archaic processes are followed, purchasing is super slow, and legal comes in. It gets messy, and often it takes a year or more to move the first application to the cloud because so many people are stakeholders, and basically the message here is don't underestimate the non-technical stuff. So we have estimated that about 70% of the challenges are non-technical, political, purchasing, legal, training people, getting rid of fears, and all of these things. And so prepare these things. And the most important thing is you hear that always: get exec commitment or nothing moves. I mentioned that I would like to clarify the models a bit. So So what you see here is a couple of examples of public clouds. So everyone knows these guys. So the big players are AWS, Google, Microsoft. So these are the big three by now. We also have IBM and VMware by now has moved over to AWS, Google, and I believe Microsoft as well. I'm not quite sure. And these are the public clouds. So everyone knows that. So that's perfectly clear. And if you operate your own fully automated cloud, that's a private cloud. And a private cloud really means that you have a portal where you can order VMs or can order container solutions, where it's fully integrated into CI/CD pipelines, and basically a highly automated cloud that you have on-premise. That's a private cloud. Now, the big question is, what is a hybrid cloud? And the hybrid cloud basically is when you combine your private cloud with a public cloud, with any. It doesn't really matter with which one that you connect it to. When you're able to have one workload running here and another workload running here, that's a hybrid cloud. And then a multi-cloud strategy or multi-cloud setup is if you have multiple clouds running at the same time. So for example, you run SAP at Google, you run your digital environment, your web presence at AWS, and you run Microsoft 365 at Microsoft, then you have a multi-cloud strategy. And a bit of a special case is these virtual private clouds. Virtual private clouds is basically a private cloud that is outsourced to a cloud provider. And here in Switzerland, we do have a few of those. I don't mention them. Everybody knows who they are. And there you get your own private cloud. And that is basically like a virtual private cloud. Only you have access to that. You don't share much. And it's very close to outsourcing, but it is fully automated. You probably have seen that. I just got that recently from AWS. These are the players on the cloud market, and everybody knows that. But AWS is still in the infrastructure as a service market. AWS is clearly the leader in terms of services and mind share. They're really doing a great job. Unfortunately, not in Switzerland in terms of regions, but many clients they can work with the Frankfurt region or Milano or Paris, depending on where they are, or even with Outposts. With Outposts, there are good solutions where you can bring the AWS cloud into Switzerland, either hosted at a service provider or in your own data center if you want to do that. And then Microsoft is catching up greatly. So they have very good growth rates, putting in a lot of efforts, doing a lot of good things in the open source world as well, and really strong on containers. And Google is actually doing really well as well on the technology side. Both Google and Microsoft are doing really well. And then there is a big gap to Alibaba, Oracle, IBM, and so forth. And everyone wants to play in the cloud market, but the lead that Amazon has is so amazing that probably only Alibaba will be able to move up into that leaders quadrant over the next 3 to 5 years, because Alibaba obviously has a stronghold in China and in Asia because they are a Chinese company. Good. Now coming to the interesting stuff, well, most likely why you are here. So we are 22 minutes in, but we should be fine timing-wise. So what is AWS offering? So the offering of AWS is just absolutely stunning and amazing. If you open an AWS account and you click the first time on the drop-down menu where you see all these offerings and all these services, you will be blown away because you don't know what to click because they use such crazy names like Lightsail and EC2 and S3 and Route 53, and nobody knows what that is. And I criticize that a bit because the other folks, the other providers, they are doing that a bit better. They really call it as it is. It is compute and storage and containers and so forth. But you get very quickly used to those crazy names. And they are really funny names often too, because Route 53, for example, which is their DNS service, is a routing service to 53, which is the UDP port of DNS. So they have often quite funny names that they use, which have a lot of thought built in. But as a starter, it's really hard to understand what service that you consume. So what they offer, obviously, is a global infrastructure. So they have, I think, 24 or 25 regions by now. It's a lot of regions globally, and each of those regions at least have 2 availability zones. And that's super important that you understand that, because some other public cloud providers, they spread around that they have 50 regions or 80 regions or anything like that. But if you look at it, a region of them often is not with multiple availability zones. And we do have exactly the case here in Switzerland. So one of the providers has 2 regions here, but those regions, they only have 1 availability zone. So it doesn't really help much if you want to build HA setups. So when AWS does a region, they do a full region and have multiple availability zones that you really can run a professional workload on those regions. Then an extreme good setup with cloud, with computing stuff. So basically VMs, containers, serverless, or combinations of those. It's really fine-grained what you can have in the computing space. I mentioned serverless, that's part of computing, and the deployment technologies, storage, database things. Database is also quite huge. I have a slide to that, what AWS offers there. Then networking, obviously, if you build something on AWS, you want to have your own network, and actually AWS Prime software-defined networking, they don't call it like that, but everything that you define as AWS with networking is fully Microsoft. So you have your own networks, you have your own subnets, and you have your own security groups, and obviously, because it's global, you get a great content delivery network as well, and fully managed from AWS. And the whole security, identity, and compliance services, really cool what is going on there, and more and more also combined with artificial intelligence, so that you can get the best of both worlds, security and machine learning, artificial intelligence combined. Messaging, Kafka, their own queues that they have, and other messaging services, analytics, business intelligence, data services. The list is almost endless. So they do have by now, I think, about 185 services that they offer. It's quite a lot, and most likely the right services are there for you as well. Here is a list of a few services that you can get, and I can't go in all of those, but it's not only that the platform services that most people know of, it's also application services. So what they do is the application services are combined with the platform services. So for example, if you want to do notifications, sending SMS or emails or mobile app notifications, they put their software onto a container, and then you consume the notification as a service. The same for queuing. So for example, if you want to have a Kafka cluster, it's really easy. You get a managed Kafka service, and then it consumes platform services below. Here, start from the security and management area. So it's keys. It's really cool what you can do with bring your own keys, manage your keys, so that's always the data is always encrypted. Identity and access. So really everything is controlled that you configure and that you access. So if you want to consume one of those services, it has to go through identity service. So that's a base thing that AWS puts in always. Of course, the infrastructure that they have here, then they have the possibility of connect with your own environment. So direct connect, for example, is a direct lease line straight to your on-premise network. You have backups really well solved with snapshots and support, and of course, because everything is an API at AWS, you can integrate it into your existing management systems that you have. And here, because AWS cannot do everything themselves, they have a huge marketplace. And so, for example, if you need anything that AWS doesn't provide themselves, you can go into their marketplace and fetch licenses and even software and provision that software straight onto the platform services, so that you don't have to mess around with licenses or with software. So, for example, lately I installed SAP HANA for a test. I wanted to see how that goes these days. I went into Marketplace, searched for HANA, provision at HANA in probably half an hour. It was a couple of clicks, and then I had a HANA GUI, SAP HANA GUI to access very easily, and the license was charged to my AWS account, which I stopped quickly because that stuff is really expensive. So running that for an hour cost me probably $50 or so. So turn it off all the time, or else your vacation budget will go to AWS. And of course, technology is not all. You also need support, training, professional services, and all of these things. And AWS these days is really mature, and also their sales are quite well established. Here in Switzerland, they have a huge team. It's really great to see how they are bringing an end-to-end service to clients. And of course, we have partners as well. We shouldn't forget ourselves. So we do have dedicated people at AWS that help us as well when we implement something at clients and can do it ourselves, need help, and then we have solution architects at AWS that help us as well to implement those solutions. Good. When you haven't built on AWS, you don't know what they are actually building. And here I put up a drawing that is quite common, that is built on AWS. And that's basically an application that uses a multi-tier environment. So you see here the front-end layer. This could be the application, the web tier. This could be the application tier, and this is the database tier. So let's start at the back. So this is an RDS. Could be anything like MySQL, Maria, Postgres, Oracle, Mongo, whatever. So with a few clicks or with CloudFormation templates, you build a fully redundant database that is fully replicated over multiple locations. Then you have here the compute tier, which we try to build often in an auto-scaling way. So, for example, this could be the API layer that is doing computing or whatever. So this is Linux instances, Windows instances that are run on virtual machines. And because it's auto-scaled, it is all stateless. So all the data is stored in the databases so that we can treat these instances as cattle. So if it misbehaves, the load balancer kills these instances and a new one comes in. That's quite ruthless how that is handled. You don't have to do it that way, but these are patterns that AWS recommends. And here is another layer of compute. These could also be containers. For example, these could be Nginx containers running the front end, doing whatever you need. Then again, a load balancing. Then we do have CloudFront for the CDN. We have S3 to store whatever you need to store, video files or images or whatever, and here you see DNS. So this is a typical example what is built at AWS with the services that I have mentioned before. This could be Magento, WordPress, other PHP applications, or full-fledged SAP or Oracle, whatever application you want to put on these environments. And this is actually quite a classic thing with compute VMs. Obviously, you can build these days as well with containers or even serverless if you want to. So to the foundation services, what is an account? Don't confuse an account as a user account. An AWS account is really the thing where you put in all the resources. So an AWS account basically holds the databases, the VMs, everything that needs to go into AWS is part of an AWS account. Of course, an AWS account needs to be secured, and for that we have EOM for the user, passwords, key roles, directories, all of these things. This is all handled together with the account. Of course, the whole billing goes in there as well. So all the cost reports, the budgets, consolidated budget, cost optimization, that is all very much linked to an account to foundation services as well. And then the whole monitoring, when you put something into a public cloud, you want to have it really well monitored, and obviously that is running in those AWS accounts too. These days, when AWS provisions a well-architected setup, there are 5, 6, or even 7 accounts provisioned for an application, and that could be for cost, security, for logging, for the compute, for testing, for all of these things. So an account is free. Provision as many accounts as you want, and link them together on the control side, but also on the data plane side, so that you have the correct linkage. Moving on to networking, when we have an AWS account, and you see that here, that is an entity, and then you put in a VPC. The VPC is a virtual private cloud, and that's basically your own network that you create. And inside of that VPC, you can have as many subnets as you want. So you can have private subnets where you put your databases and your compute. You can have public subnets where you put in your load balancers that you connect to the internet. And then you have the supporting services that the internet traffic can come in, like the internet gateways, internet gateways, or the virtual private gateway, so that you can connect your own network to the AWS account. To compute, and here you see some of those funny names that I have mentioned before, and I have tried to split up compute into the 3 different application execution environments, how we call them. So into the classic VMs, into containers, and into serverless environments. Here you run a full operating system image as a VM. So that's the same as you do today with VMware ESX or with Hyper-V. That's basically an EC2 is very similar to that. If you go to, let me finish on VMs. Lightsail is something that AWS has created for smaller customers. So if you want to put up a WordPress instance or a PHP instance, you can very easily do that with Lightsail. And Lightsail is basically an application in a box, but it runs on VMs. So it's super easy, but it's also very inflexible. So you can't do much. If it's WordPress and nothing else. Here on EC2, you have the full flexibility, but you also have the complexity of the full VMs. Then we go over to containers. So the containers, we have ECS, Elastic Container Service. That's AWS's proprietary container solution so that you can run your Docker images very easily on ECS. You bring the Docker image, you bring the configuration, in a few minutes your container is up and running without doing anything. Particularly if you use ECS in Fargate mode, it's super easy. Everything is handled from AWS. You just bring the image and off you go. And then with ECS for Kubernetes, or EKS as it is called these days, that's basically a fully managed Kubernetes service, and you can also have that in Fargate mode these days. It basically is a fully managed Kubernetes cluster for you, and in Fargate mode you don't even have to manage the nodes. And here again you pay for the container as it consumes CPUs and memory and storage by the second as it runs. And Lambda, this is quite fancy. It's really cool stuff, but in most cases you need to rewrite your application to use it. But if you bring a new application to AWS and you code it from scratch, look if you can use AWS Lambda. It basically runs your code without having any infrastructure to manage below. Really cool, but it's a rewrite. To storage. Here again, I have categorized their storage services into 3 different areas: object storage, file storage, and block storage. And the storage is very confusing for many starters at AWS because they don't know what to use. If you go price-wise, object is cheapest, file is in the middle, and block storage is the most expensive one. What is it? You may know it. Block storage is really SCSI blocks that you put onto. So it's your boot disks, it's your disks attached to your VMs. That's the EBS volumes. You need those if you use VMs. File storage, here FSX for Windows, that's basically a fully managed Windows service where you can run CIFS and SMB protocols, so file shares or anything like that, put them on FSX Windows protocols. It's really cool. In probably half an hour with a few clicks, you have a fully redundant Windows file service solution on here, and you pay by the gigabyte that you consume. And here is the same thing in NFS. So you have here a Linux-based file server system that you can consume. So you define EFS, you get the NFS shares to connect to, the NFS mounts to connect to, and off you go. And here also you pay by the gigabyte. And object is S3. People know by now what S3 is. So S3 is really to dump any kind of data on it that you consume as an object. So images, videos, log files, archive, all the stuff that you put there and basically just want to read. Obviously you can write, but it's not meant to use it to do, for example, a Microsoft Doc collaboration. A Microsoft Word Doc collaboration goes onto an FSX. Here you really put images and videos and stuff like that onto here. And then you can archive these things, and these 2 are migration solutions. A Snowball is basically a suitcase full of disks that Amazon sends you, and this here is a truck full of disks, multi-petabyte storage that you can use to migrate all your huge systems onto AWS. Good. A really cool area is databases, and AWS has lots of databases. And these are all fully managed databases. So it's not all your own, so you don't have to go and start your VMs and do a yum install MySQL or Maria. It's really you go and start an RDS and say, I want to have a fully managed Postgres, a fully managed Oracle. If you want to have replicas, just put on a statement, I want replicas. If you want to have it HA, just put a statement, it should be HA. And then it spins up a multi-AZ Postgres instance for you. And that's true for all of these database technologies. MySQL, Maria, Postgres, Oracle, MS SQL, MariaDB, the SQL databases, all are fully available at AWS RDS, in RDS and RDS Aurora. In NoSQL, we do have Mongo, so that's a document DB, and we have DynamoDB, which is a classic key value store where you can put in your key value stores. And particularly DynamoDB, super cheap, super easy to run. You can have billions of rows in there, and it's still cheap. So if you have the flexibility to use DynamoDB for your key value store, look at that. It's really, really, really cool technology. And then specialized databases. So, for example, graph databases, something that Facebook has primed. There you can have the open source technology Neptune. I can't really remember what the name is there. So graph DBs with Neptune. Time series databases, so where you want to put in a lot of metrics, for example, IoT sensor logs or so, it's time stream. Then in-memory databases, Redis, Memcache, also available as services. And by now, even blockchain things as ledgers, immutable databases, it's all there. It's all fully managed. Don't worry about patches and security and backup and all these things. And you just provision, and probably half an hour later, it's up and running. So now coming to development, DevOps things. So when application developers want to provision code onto a cloud, they usually want to work with their favorite tools, with their IDEs and GitLab and so forth. And obviously, AWS puts a lot of effort into enabling developers to put applications on the cloud. They have a full tool chain that you can use to really have a really cool CI/CD pipeline at very low cost. So you push code, it builds it, it deploys it, and at the end it runs as infrastructure as code on the AWS platform, so that you have a fully integrated platform. Why is that important? Many companies, they have started to build software in an agile way. So they go through the sprints, they have multiple sprints, and as you know, at the end of each sprint, there is a software increment that should be provisioned. And with these CI/CD tools, the DevOps integrations, you really want to bring these software increments into production. You don't want that you have to wait half a year until operations is ready to launch that software increment into the production environment. So you want to link up development and operation. So when a new software increment is produced, that it really runs through all these different testing and stages, staging environments, and in best case, if the tests are successful, even go to production automatically. So that is what you can build at AWS with the tools below. So a developer can commit into, or can actually build with Cloud9, which is their IDE. They can commit into a Git repo, can also be Git or GitLab or anything that you like. It is built with code build, which is basically a build service comparable to Jenkins, but without the overhead of maintaining a Jenkins environment. It builds the code, and that works for Java, .NET. It's a lot of languages that code build supports, and then it hands over these VMs or containers or even Lambda functions and deploys them with CloudFormation into the cloud. And that is all controlled via code pipeline. So code pipeline basically controls the whole process, so that you have an end-to-end view what is going on. Good. So we come to the closing. I have to hurry a bit to the last two slides. Sorry about that. I talk a lot when I'm in flow, and I have been in flow right now, really. So it's now time to open up for questions. Please put in your questions into the chat window so that I can go through your questions, if you're still here, obviously. So no questions are coming up. Somebody can please just write if they are still there. Yes, good. Yes, I see quite a few people chat here. Thank you so much for that. So as I'm already a bit over time, I don't want to stress your agenda more. Here at the closing, thank you so much for joining. Thank you so much for being here, spending 45 minutes with us. Don't forget, this is a webinar series. So the next one is already on the 24th of August. It's together with Simona. It's an AWS well-architected session. So this one is going in quite deeply into how you should architect AWS so that it is well architected, it performs well, it's secure, it costs optimally, all these things. And you can register as always on copit.clickmeetings.com. And if you have any questions, reach out at info@copit.com. We are here for you. If you have any project, if you want to work with us, reach out. We are here and we can help you with these AWS projects, container projects, anything that you need in the cloud area. Thank you so much for joining. See you soon at the next webinar. Thank you and goodbye.